every time you stream a movie, post on social media, or ask an AI a question, you're using the cloud. But here's the thing. This cloud isn't some weightless, fluffy thing floating in the sky. It has a very real, very heavy, and honestly, a very hidden physical cost. So what is really going on behind our screens? Let's take a closer look. Okay, let's just start with a single number. 2,967 terawatt hours. That's the projected energy our data centers are going to need globally by 2030. Now, to put that into perspective, that is more than the entire annual energy consumption of many countries. It's a staggering figure, and it points to a huge challenge for our digital world.
And that number? Well, it's directly tied to our daily habits. It's the power needed to host these massive amounts of data and enable everything from, just simple connectivity to the most complex artificial intelligence models that are literally reshaping our world as we speak.
All right, first up, let's really unpack the cloud's incredible thirst for power.
You see, the cloud is physical. It's made of millions of servers all housed in these massive buildings called cloud data centers, or CDCs. You should think of these as the engines of modern society. And boy, are they incredibly energy intensive.
And just look at the speed of this growth. In 2023, U.S. data centers used about 4.4% of the country's total electricity, okay? But some high-end projections for 2028 show that jumping to 12%. That's a nearly threefold increase in just 5 years. That's wild.
And the number one reason for this explosion in energy demand? It's the rise of AI. Training and running these powerful models requires a level of computational power and therefore electricity that is just orders of magnitude greater than what we were used to.
So where is all that electricity actually going? Let's take a look inside one of these power-hungry boxes. Now, here's a breakdown that really surprised me when I first saw it. Only about 60% of the power actually goes to the servers doing the computing. A massive 40% is just for support systems, mostly to keep everything from melting. That's an incredible amount of energy overhead before you even get to the real work.
So yeah, it's not just about the computers. The servers are the brains for sure, but the HVAC systems stopping them from overheating and the uninterruptible power supplies, or UPS, making sure the power never blips, well, those are also huge energy hogs.
Okay, so if these facilities are consuming so much power, the obvious next step is to figure out how to make them more efficient. And, in engineering, there's a saying, if you can't measure something, you can't manage it.
And that leads to a really fundamental question. How do we actually measure efficiency? How can we compare one data center to another and know for sure which one is wasting less energy?
Well, the industry's answer is a metric called power usage efficiency, or PUE for short. It's actually a pretty simple ratio. You just take the total power coming into the entire data center and you divide it by the power being used just by the IT equipment.
Think of it like a factory. An inefficient factory might have a PUE of 2.0. That means for every 1 unit of energy used to make the product, another whole unit is wasted on things like lights and air conditioning. But a highly efficient factory, one with a PUE of 1.1, only wastes a tiny tenth of a unit for every 1 unit of productive work. See the difference?
So the goal is to get as close to a perfect score of 1.0 as you possibly can. And to give you some real-world context here, Google reports a fleet-wide average PUE of 1.10, which is just incredibly efficient, especially when you compare it to the industry average of around 1.58. So PUE is a great start, but, and this is a big but, it is not the whole story. As we're about to see, even a fantastic metric can have some pretty serious blind spots. And this is something the researchers in our source paper point out. They say that metrics like PUE often give us only a partial view of the bigger picture. They're missing a really crucial piece of the puzzle. And here's the problem in a nutshell. A data center can have a fantastic green checkmark PUE score. Awesome, right? But what if all that incredibly efficient electricity comes from a coal-fired power plant? You see, the PUE metric tells you nothing about where the energy actually comes from.
This is the key takeaway, right here. PUE is a great measure of operational efficiency, but it says absolutely nothing about environmental sustainability. So, to address this, the industry developed another metric, carbon usage effectiveness, or CUE. Now, this one measures the actual carbon emissions associated with the data center's energy use. And here, a perfect score is 0, which would mean running on 100% carbon-free energy.
So where does all this leave us?
Well, the path forward seems to involve combining these metrics and using new technologies to create much smarter data centers.
So there are three key trends shaping the future. First is using AI itself to optimize data center energy use in real time. How cool is that? Second is creating digital twins. These are virtual models of entire facilities to test out efficiency improvements safely. And third, moving towards what they call holistic metrics that combine efficiency data from PUE with sustainability data from CUE.
The ultimate goal here is no longer just about being efficient. It's about having a complete 360-degree view that balances raw performance with energy efficiency and, crucially, true environmental impact.
And that leaves us with a final and pretty critical question. The demand for data, for AI, for digital services, it really seems infinite. But the energy resources to power it all are very, very much finite. And the challenge for the next decade and beyond will be finding a sustainable way to balance the two.